Look at this truss. At first glance, it seems statically indeterminate. There are two pinned supports that appears to create four reaction components, and in planar statics, we only have three equilibrium equations. So the conclusion seems obvious. Too many unknowns. Problem impossible. Or is it? This is a very common mistake. Students see supports, count reactions, and immediately decide whether a structure is determinate. But counting reactions is not enough. We must first understand how the structure actually works. So let's look carefully at the lower support. The support is connected to the rest of the truss through a single member, and truss members carry axial forces only. Nothing else. No bending, no shear, only tension or compression. So we immediately know something important. The lower support can only pull this member or push it, which means we already know the line of action of the reaction at E. Only its magnitude is still unknown, so instead of 4 unknown reactions, we now have only 3, the magnitude of the reaction at E and the 2 reaction components at support A. But we can go one step further. Not only can we predict the line of action of the reaction at E, we can also predict its direction. Imagine removing the lower support. Under the applied loads, the truss would tend to rotate clockwise. To prevent that motion, member ED must push upward on the structure. So member ED is in compression, and the reaction at E must act upward along the member. And this is the key idea. At first glance, the lower support appeared to provide 2 independent reactions, but it does not. The geometry of the truss forces that reaction to act along a specific direction. So one apparent degree of freedom never really existed. The structure itself eliminates it. And that is why the truss remains statically determinate. This is why counting support reactions alone can be misleading. Look at these two structures. Both have 2 pinned supports. At first glance, they seem similar, but one is statically determinate. The other is statically indeterminate. The difference is not in the supports. It is in the structure itself, in the way forces are allowed to travel through it. This example teaches a simple but important lesson. Before counting reactions, look at the structure. Before applying formulas, ask how the structure works. Because structural analysis is not about arithmetic. It is about recognizing how forces move through a structure. And once we recognize this pattern, a problem that seemed impossible becomes completely solvable. And this is exactly how we think about structures throughout the course, physics and structures made simple for architects. Not isolated procedures, but clear principles and structural intuition. If you'd like to continue building this intuition, the next lessons are on screen now.